Nevada Virtual Academy proficiency exam, juniors, seniors, everybody else. Problem, use the diagram below to answer the question. Okay, we have a segment here between 2 points, obviously, part of a line. And the question is, what is the slope of a line that is parallel to KS? You guys remember that if we have two lines that are parallel to each other, they have the same steepness, the same incline. If this one has a slope of M2 and this one has a slope of M1, let's say, of M1, right? The two slopes better be equal if the two lines L2 and L1 are parallel, right? If L1 is parallel to L2, then M1 should equal M2, all right? But to find, a line that, the slope of a line that would be parallel to KS, I need to find the slope of KS. And there are many ways. One way, remember that your slope is always rise over run. What you have to do here? Well, to count, if you want to travel from K to S, and you can do it only vertically or horizontally, you're going to find your rise by counting how many steps it takes you to get from K's altitude to S's altitude, which is 2, right? So your rise will be positive 2. And from here, I have to move to S. I'm taking 1, 2, 3 steps, right, toward the positive direction. And that's also positive 3. And this is your slope. 2/3 positive. C is the answer. This is the way you're solving a similar problem, with the rise and run. And there's another way. Remember in class what I said. Take your points. I have point S, coordinates 5 and 4. Take your point K, coordinates what? 2 and 2, and stack them up like this. Well, doing it this way, I have my X column, I have my Y column. Subtract bottom from the top, right? This gives you what? 10 o'clock. Boom, boom, dang, dang, bing, bong, boom, bing. Okay, 10 times. All right, subtract X from X. 5 minus 2. That's going to be 3. This is your run, or if you want, your change in X, right? Let's go with the Y's column. I'm going to use a different color. 4 minus 2 is going to be 2. This is your rise, okay, or the change in Y if you want. And now your slope, M, change in Y over change in X, rise over run, which equals what? 2 over 3. Well, obviously it's the same answer, but I'm just telling you and showing you a different way because some of you will say, hey, why should I use this one when I can go on the graph and just go step by step? Yes, but let me give you an example, right? How about you have 2 points with the coordinates, let's say point A with the coordinates 1001 and 0, and point B with the coordinates 1 and 1000, okay? Now, look at your graph here. There's no way for you to go on the graph and count, 1000 steps and so on. So the best way will go to, do the differences like we've done in here. You subtract X from X, Y from Y, right? And you find the change in X to be what? 1000 minus 1, that's 1000. You find the change in Y, which is 0 minus 1000, which is negative 1000, right? That's your change in Y, if you want your rise, right? The other one is your run. And that's how you find your slope for this problem as being rise over run, negative 1000 over 1000, which is negative 1. And like I said, there's no way to use this graph. Actually, there is a way, don't get me wrong. There is a way to use this graph in here, but if this will be, 1, 2, 3, 4, 5, 6, 7, then it would be kind of tough. Anyway, you probably got the point. What I'm trying to tell you is that sometimes you cannot use the graph to count and to calculate your slope. So better be ready to use a different way, a different approach, which is this one, where you work only with the coordinates of your 2 points. Okay, or sometimes the graph may not be given to you. So what are you going to do then? You know the coordinates, we don't have the graph. Are you going to be stuck? No, you're going to use the stack up method, if you want to call it this way, and just subtract, just find the differences between your x's and y's, and this is it. Okay, thank you.